What's up, YouTube? Today we're going to be talking about dependency injection. It's one of my favorite topics to talk about. I don't like it. I don't like dependency injection. I don't use it. I have used it, but I've been reformed. I've used it a few times in large systems, production systems. In one case, I've also modified a project of my own, and I have learned through other people's experiences, other teams that I've been working with or colleagues, and most of the experiences have been bad or not pretty. Now, I realized that there are a lot of people using dependency injection. A lot of people believe in it and find value in it. And that's fine. If you're seeing value from dependency injection, yes, use it. So be it. But there are some assumptions being made. There are some things being overlooked, and on and on. So that's what I'm going to talk about today. Now, keep in mind, these are my experiences mainly. Of course, I'll tell you about things that other people have also said, but actually, you know what? I've been thinking about this. You guys can probably put this in the comment and let me know what you think. Or maybe I'll put out a vote, a poll, and ask you. So there's a bunch of people I can talk to at work who I can interview, if you will. And I have spoken to them about it. A lot of them have agreed, and I'm sure I can catch others. Not in this video, but another one, because it'll get too long, or a series of them. I'm not sure how many people I'm going to be talking to and how long those discussions are going to be. But if you're interested in that, where you're hearing other people voice their opinions, they're good or bad or otherwise, let me know in the comments, or if I do put out a poll, please go and vote there so I know if there's an interest in it. So what is dependency injection? What drives it, or what is the motivation behind dependency injection? Dependency injection is an implementation of inversion of control. Inversion of control is very closely related to dependency inversion, which is the D in solid. So what is dependency inversion? If you have a class A that depends on class B, dependency inversion is saying essentially that rather than A depending on B, A should depend on an abstraction. So think of like something in the middle here between A and B, let's say an abstract class or an interface. A should depend on an abstract class of this class. And of course, so A should depend on this, and then of course, since this is a descendant of the same abstraction, they are both depending on the abstraction. So rather than two things depend on each other, or one thing depend on something else, A depending on B, A should depend on the abstraction of B, and then B of course also is depending on the abstraction, and so you've kind of inverted the dependencies. In concept, I think the principle is solid. What? Yes. It's a solid principle. Yes. What I mean is in concept, the idea of dependency inversion is sound. How's that? It's sound. You can't fault it. My problem with all of solid is that people believe that they should be following these things, and every single thing in their system and every system of theirs should follow these principles. And I think you kind of lost the point with those things. And maybe there's people that say that's what you should be doing. Either way, I have a problem with that. Understanding a principle or a technique or a technology and then dogmatically using that all the time, I don't think that makes it correct. If it's being used for the reasons that the principle or the technique is supposed to be used for, and you actually need it, yes, it makes total sense. If you're using something just blindly because that's what people tell you or that's what you think you should be doing, I think that's an incorrect use of a good thing. So dependency injection is a sort of a form of inversion of control, which is similar to or conceptually the same idea as inversion of control, not exactly, but dependency inversion. And inversion of control is more to do with trying to make systems more modular, more extensible, reusable, and on and on and on. And I have a problem with that as well. Do I understand the premise or the idea of extensibility, reusability? Yes, of course. But over the years, what I have have concluded, just as it sort of just happened, is extensibility and reusability are the reasons software systems are unmaintainable. You cannot understand these systems. It's very difficult. I'm not saying you can't. It's very, very difficult to understand these systems, especially if you weren't part of the building of the system or the design of the system. Most of the bugs come from the areas that are trying to do the extension, the reuse. So over the years, I've concluded, nothing to do with dependency injection per se, but my conclusion is to hell with reuse and extension. Just don't bother about it. Don't start thinking about reuse and extension. Maintainability trumps everything. If a system can't be maintained, it has no point or meaning. And I think the problem with these three things, extensibility, reusability, and maintainability, are they're at loggerheads with each other. You either get a system that's maintainable, and of course there's degrees of sort of maintainability / reusability, but if you're going this extreme on reuse and extension, the maintainability is not maintainable. It's kind of going more towards that, and so you're losing maintainability. So building a system to be extensible, I don't know about that. You shouldn't start off that way. You're supposed to be building the system for the business that you're building it for. By business, I mean the thing is supposed to do, and it should be maintainable. If you do that, of course, with the assumption that the design of the systems is correct, right? So there's no connection between if a system is not reusable, it's badly designed. That's not true. If the system is not extensible, it's badly designed. No, it's not true. What is bad? If I don't need to extend, this design can still be great. I just don't care to design for extensibility. You can't call it bad design. You can say it's not extensible. Yeah, that's by choice. Okay, so with dependency injection, there are different forms of dependency injection, like constructor injection, property setter injection, interface injection. Some people even call just sending our primitive types into methods is called method injection. I don't agree with that. But before we can go on with this discussion, I want to sort of set the stage for certain things, because there are a lot of assumptions being made by people who follow dependency injection, I don't think everyone, but there are certain sets of people within that group where they say, okay, well, if you're not doing dependency injection, your system design is crap. Literally, they don't use the words like that, but that's what they're saying. Or your class is not single responsibility because you're not using dependency injection, or some connotation of that. So for the sake of this discussion, this is what I'm going to say. Let's agree to a certain set of things. One, given a certain requirement, we decompose the system into different classes. This decomposition is an agreed upon decomposition, meaning we agree that the decomposition is correct. So there's no argument about single responsibility and whatever. And so let's say we have 100 classes. Then these 100 classes are participating in the dependency thing, like whatever it is. Some could be that have dependencies, others are the dependee, I don't know, whatever, you get my point. So of the 100 classes, now the question is, should I use dependency injection to inject the dependencies or something else? That's essentially where we want to be at. So the argument of this system is not designed correctly and all that can be thrown out the window. And we're not dealing with that nuance, all right? One of the other presumptions that people make when they're using dependency injection and you say, you don't use it or you don't like it or whatever, is that you can't test. Besides, your system is not designed correctly, they say, but then you can't test. So before, I go on and rant about dependency injection, and I'm sort of foreseeing this as a multiple part thing, you should know this. You can test everything you need to test just the way you do with dependency injection, but without dependency injection and without mocking. Now I'll make the testing part of the videos as a separate piece, another part, because it's slightly different from dependency injection, but nonetheless connected. But you need to know, you can get all the benefits, claimed benefits of dependency injection and mocking without using dependency injection, without using mocking, and a lot of the demerits, if you will, the cons of dependency injection, as I will mention them further in this video, you won't have that. How? Well, that's the secret. I'll tell you how, but eventually, I'm not trying to hold out on you. It's just I want to kind of go in a certain flow before I bring all this stuff in. But just so you know, dependency injection and mocking give you some benefits, but there are a lot of cons. What I'm going to recommend to you also gives you benefits, and there are cons. So for me personally, and for people that I've worked with who have seen the light, the cons that you get with what I do is well worth the cons are well worth it, or the trade-offs are worth making, or okay, because the trade-offs you have to make with dependency injection and mocking are not. Right? It's a choice you're making based on what trade-offs you're willing to make or not. Nothing's perfect, so there are trade-offs. The question is, what trade-offs do you are willing to make, and what trade-offs are you not? Okay, so my question to anyone that is a fan of dependency injection or has used dependency injection and likes it is this: do you know of anything else that can do that can satisfy the need of satisfying dependencies? If you don't, I'm sorry to say, but you've not been doing your homework. You haven't experienced enough or something of that nature. See, there are about 3 kinds of people when it comes to this. One is the kind of person who is just sold. Dependency injection is it and nothing else will do. Right? Okay, fine. So there's nothing you can do for these people. Nothing, you can't have a conversation with them. So I'm just going to exclude that set of people. The second kind is there are people who they don't know enough, they haven't had enough experience, they're on a team, or they've been told to do it like this with dependency injection. They're ambivalent. Either they have a certain opinion but they're not quite sure, or they're doing it because they've been asked to do it, or they see some sense or some benefit to it, but not necessarily the benefit that dependency injection itself espouses, but they're seeing some value, but they're not quite sure. Okay, that's fine. I mean, you can't be faulted for that. I mean, you don't have enough experience, you don't have an opinion, you can't see the problem Or if there's a problem, it's kind of, well, that's just how it is, so therefore, I'm going to do it because you don't know any better, right? Which is fine. I mean, that's a part of growing up. That's part of the learning process. The third kind of person is someone, and maybe there's a fourth kind of person. These are people who haven't had a whole lot of experience, but they got huge amounts of opinions. This is a breed of people that I meet a lot. They don't have a whole lot of real world experience. But I mean a whole lot. I mean, experience is about the amount of experience and the quality of experience, right? It has to, you can have 10 years of experience, but doing not much or not, interesting, challenging things, then that 10 years of experience is not amounting to much. In the same 10 years, if you did a wide gamut of things that had all kinds of challenges and problems, then you're better for it. These are typically people who read up somewhere, blogs, videos, books, whatever. They immediately formulate an opinion. They're able to extrapolate from what they read and learn into these scenarios to a certain extent. They can appear like they know it. They can appear like they've done it. But anyone that has had experience can very easily can see past that. And it's sad, but it's true. I meet a lot of people like that. They will happily go along with this technique or that technology, probably because it's sort of, again, a conformist thing where you're conforming to something other people are doing, so you need to learn about it. But you haven't quite exercised, you haven't had the experiences of looking at it from this perspective and that perspective and this scenario and that scenario to kind of have enough experiences over years to then have a conclusion or an opinion based on that. And it's sad, but it's true. And unfortunately, because you can see through this, they don't quite look well, I'm not going to say much. You can see through it. I've had experiences. They may not be good. They may not be bad. It may not be enough. But from everything that I've done with dependency injection and having given it a fair shot, I didn't know not to. But learning, as I said, I've been reformed. I went through the experiences. They were not just my experiences. They were, I was working in teams, and pretty much everyone on the team came to the same conclusion. We all had the same kinds of problems. We all had the same kind of heartburn or heartache with dependency injection. And we are building in two different companies, two different systems. I built systems in parallel, meaning it's the same class. I can see that the idea was the decomposition is the same. All we're deciding is should we dependency inject or not. Right? That's basically the difference. And in both cases, for any number of reasons, the teams decided that it's best not to use dependency injection, and because we were building these things in parallel, we decided at some point that we were just going to further the other source that had the same classes but was not be there where the dependencies were not being injected. All right. Of course, over the years, I've also had a bunch of people, as I said, that have terrible experiences, from debuggability to runtime exceptions to people when they join the teams are just having a hard time understanding the system. The complexity of the system has kind of bloated up and it becomes very difficult. On the other hand, I've had people who joined my team. They were big fans of dependency injection. Once they learned that we don't use dependency injection on the team that they're on, they were a bit apprehensive and a bit, I guess, disappointed. But I have to tell you, by the end of the project, they have been convinced, they have been sold. And to me, these are telltale signs. You come from the dependency injection world and you're, let's say, open. You have to be open. Right? There's this saying that people say, seeing is believing. Right? That's incorrect. From everything I have learned and experienced about humans, including myself, I'm not disconnecting myself from this. Believing is seeing. You can't see it. If you don't believe it, you will never see it. If you give yourself the opportunity to see it, you can be convinced. Right? So luckily for me, these are people who were accepting of the fact that there's another way to do this, even though they came from the dependency injection world. And they've actually told me after the project or whatever the case may be that I was working with them on, I would never use dependency injection again. That's just how it is. Okay. Now going into the dependency injection, the other conversations I've had was where people would say, well, it depends on when I use dependency injection. Depends on what. So they'll give me a reason for when they would use dependency injection. For me, there's polymorphism. And the reason I say is polymorphism is that since my classes are self-contained, if I have a need for a class to have different behavior runtime, meaning this is a business requirement, and the way I've implemented that requirement is through polymorphism, then that is internal to the class or classes, the composite of classes that make up the feature. I don't need to inject. I guess what I'm trying to explain is this. For some people, the only way to swap out behavior is to inject the behavior. So they would have implementations of, let's say, 3 different ways to do something. And then at runtime, they would like to inject the right behavior into the one class that then apparently uses this dependency. My problem with that kind of thinking or that style or that design is, and I'm not sure how they arrive at this, but it seems to me that the IOC container is now deciding somehow at runtime to give you an instance of A, B, or C, as in the 3 implementations. I'm pretty sure people who are kind of ardent followers of dependency injection would disagree with that use of dependency injection. I don't know for a fact, but I'm pretty sure that would be a bad idea because you're now getting the container, the IOC container, to make those decisions when it should not be. For me, those decisions are internal to a class. I mean, yeah, I've made videos on the strategy pattern, right? Or there's the template method pattern that I've made a video on as well. These are examples of that. To me, that's internal. Maybe using a factory, like with the template method pattern, maybe I'll use a factory, the way I define a factory, by the way, wherein the factory will issue one of the many descendants, and the factory will be given some business information that will help it decide what instance to instantiate and give it back to you. But to think that you are using dependency injection for that purpose, I think actually is terrible. It's like one of the worst things you could do is use dependency injection to inject different behavior at runtime, because then the IOC container will have to decide. And why should it be doing that? There's way too much knowledge. You can imagine you have 50 different places in your system that need different behavior. And now your IOC container is going to make those 50 decisions. I think that's insane. That's just a bad idea. But nonetheless, there are people who will say they'll use dependency injection sometimes within the same system. They'll use it sometimes and not sometimes. I think that's a bad idea. So you can't mix paradigms, and I don't think you should mix paradigms. It just gets too confusing in the system. I tell my team, consistency is key. It trumps everything. Even if you're doing something incorrectly, if you're consistently doing something incorrectly, it's easy to fix. It's easy to find those patterns and fix it when the time comes. But being inconsistent is not a good idea. So if let's say you're trying to stay away from dependency injection and you're saying I'll do it sometimes and not sometimes, I'm saying no, just do it all the time. In my mind, in my opinion, dependency injection is a like an all or nothing thing. It's not a sometimes thing. I think that's just a bad idea. Now, just to be sure, I never ever use dependency injection. There's not a single reason for me to use dependency injection. So if you can't handle it, this is the time to go. If you want to learn how or why, of course there's no coding in this video, it's simply talking, so I'll try and explain it. You're gonna have to figure it out by yourselves. And of course we'll be talking about testing, mocking, especially because apparently dependency injection and mocking can always go hand in hand. I know a lot of dependency injection enthusiasts will say, but you don't have to do mocking. It's not about testing. Well, it turns out in the real world it is about testing. So, and that's my sort of the segue into this. The benefits of dependency injection is inversion of control, and then indirectly, if you will, testing. For some people, it is all about testing, and others will say, well, it's not about testing. We've got our own reason for dependency injection. Testing is a side benefit. All right. So for the most part, I'm going to demystify / debunk those things. And of course, there are reasons or there's a certain way in which I'm going to tackle it. Inversion of control, dependency inversion, where the class A and a class B, if class A depends on class B, A should depend on an abstraction, and B therefore also depends on the abstraction because, let's say, a descendant or implements this interface. So it's both depend on the abstraction. The question really is, do you need it? As I said, I understand the premise of dependency inversion, and I agree with it. I think it's a totally sound premise. But do you do this for every single class in your system? Is that really what you should be doing? Or should you be doing that as and when you need it, or in areas or places where you need it? So of these 100 classes that we have, are you saying that every single dependency should be ready to be swapped out for a different implementation just in case? This is where my problem is. We are building systems for just in case. We have the audacity to think that we can imagine every single direction and angle that a business and or the system can extend in or move in. I think that is insane. Yeah, I tried it too. Of course, I thought I could do it. And I tried it, and I tried it, and I tried it. And how many times of all the trials that I had, all the systems that I built, did I hit the nail on the head? No, it's very difficult to get there. We're imagining scenarios, we're imagining extensions that in certain directions or certain angles, and the actual extensions go this way, or they slightly just miss the the thing you were thinking about imagining. It's very difficult. In the meantime, you're complicating the systems with all this indirection. Indirections, when needed, are valuable. Indirections, when imagined, are pointless and a waste of time. If you are going to build a system to be so extensible that you are injecting every single dependency just in case, that's a huge price to pay. That is not something I do. I'm not willing to make that trade-off. And this is the problem with software design, software systems in general. Extensibility and reusability. I don't do that. Now, are my systems extensible? Yes. I don't leave the hooks in place. If you design your system well, if you decompose your classes correctly, they will be extensible. With no effort at all, with hardly any effort. Sorry, not no effort, hardly any effort. But to have an interface or an abstract class because of this dependency just in case, and then therefore you have all this clutter of all these other abstractions, whether it be interfaces or base classes, just in case, that is too much. That is a price I'm not willing to pay. It's not worth it. If anyone tells you that there are no problems with dependency injection, or forget dependency injection, anything, doesn't matter what it is. You say, I love this technique or this technology or this principle, okay, and I ask you, what are the cons? And you say, well, there aren't any. I have no respect for you. I don't mean it like on a personal level, right? What I'm saying is, you have to know the pros and cons of the things you choose to do or not do. Either ways. In fact, I say, you need to know the cons. There is no perfect system, there's no perfect technique, there's no perfect anything. So the best we got is understand the cons, understand the trade-offs, and decide based on which trade-offs you're willing to or not willing to make. Your choices should be based on the demerits, the cons of things, not the pros, but the cons. Because if you choose this thing because it's good, you have no idea what the bad is that's coming along for the ride. That is crazy. I mean, that is insane. How can you get somebody to pay you for something you don't even understand what it is you're doing or what you're getting them into? That is dangerous. Now, you may be able to recover from it, but I'm just saying, like, you are getting someone to pay you, whether it's a salary or as a consultant, money for choices you're making where you don't understand the cons. That is crazy. Anyway, so my first argument with dependency injection is this. I don't like the fact that my constructor is exposing all the dependencies. I just don't like it. I don't care to expose the dependencies. Now, the people who believe in dependency injection will say, well, I like it. But for what? Why? I just like it. I like to know my dependencies. I'm saying, but I don't need to know my dependencies. Well, they say, well, I like to know the dependencies. Okay, but for what purpose? Like, where's the value? They'll come up with all kinds of reasonings for it. None of those reasonings are either valid or are worth the trouble that all of that dependency injection causes. The way I see it is this. And just give you a hardware example. I think it's a little more, it does a better job of explaining things. And I'm hoping most of you have seen some portion of the hardware of your computer, right? We have a motherboard. We have slots for memory chips. That is our RAM. We have slots, PCIe slots for graphics cards and hard drives and video capture cards and sound cards and voice boards and so on and so forth. These are the interfaces, right? That's where the word interface came from. At least in the technology side, from the electronics world. So the idea is you can, if let's say you bought a machine with 8 gigs of RAM, you can swap out those 8 gig chips for new chips. There are 32 gig RAM chips. It just works, right? Now, the motherboard is dependent on the RAM chips, but the RAM chips are in themselves a plethora of other objects, other dependencies. That RAM chip is not a single thing. It is with thousands of little things on it. Do you want to design your classes in such a way that you as the consumer are now responsible for having to know of all the dependencies of the thing you want to use? Really? I am never interested in knowing the dependencies of the classes I use. Never once have I wondered. Never once do I want to know. I don't care. I don't want to know. I've never wanted to know. Can you imagine buying a graphics card and trying to plug it into your computer and you have to tell the computer to give you all the parts that fit on that graphics card? That's insane design. That is totally insane. Now, The problem with human nature is we try and justify what we like. We come up with all kinds of reasonings for what we want to do, not what we should be doing. We come up with justifications for what we want to do. We rationalize it. So if you're telling me that you love constructor injection because you like to see the dependencies and you cannot give me a damn good solid reason for it, you're just rationalizing it. Anyway, I'm not going to beat the horse down here, but that's my problem. My design choices are I don't want to know. It's like that graphics card that's got 1,000, 2,000 components on it, and I can just simply plug it in and provide it to the motherboard. So the motherboard has a dependency on the graphics card, but the motherboard doesn't want to know the dependencies. That graphics card stands by itself. If I'm using an object, for me it's a black box. I don't want to see inside it. I don't want to know how it works, but it has to work. I should be able to say new and it starts to work. That's it. If I can't simply new up the thing and it is fully functional, it is useless to me. Now, does that mean that, remember we talked about the 100 components and then the decomposition was correct? That's still valid. Let's not assume that I don't know how to design my classes, therefore it's all one big ball of mud because I newed up this one thing and I never saw its dependencies. I don't want to know its dependencies. There are the same dependencies, right? The design is the same. The decomposition we talked about is the same. I just won't inject the dependencies. Now, that's my biggest issue with dependency injection. The design of the classes with the constructors exposing the dependencies, I don't like. I don't want to know. Classes for me are black boxes. They're encapsulating their functionality. I don't want to know how they work. I don't want to know what they need. They just bloody well work. New, blah, and so on. Now, along with that, people will say, but then how do you plan to test? Now, I'm betting most people are using dependency injection for the sake of testing. They would love to say, oh no, that's not only it. And they'll espouse the single responsibility and the dependency inversion principle and right. It's testing. Testing is driving this whole thing. So I'm going to stop here with the dependency injection part, and I'll continue on and as a part 2, and then maybe a 3, 4, and 5. I don't know how many there are for the other interviews that I'm hoping to do next week sometime. Well, I don't know when you're seeing this, but at a later point. But we can go on with this thing, and this has gone on quite a long time. I'll try and keep them short, but this has already gone on long enough. But the basic premise of dependency injection, I think, has been sorted out. I've addressed it. The next step is the mocking part, which is closely related. So if you want to watch this next part, I will see you next time.